All right, guys, sorry about that. So as I was saying, we have to be familiar with the different cards in the card pack when we are doing probability, because a lot of the questions that we may be doing may have to relate to the card pack for that. It's a common practice to use the card pack when we are looking at probability. So here now, to find the probability of drawing an ace. Now, what would be the probability of drawing an ace if you are in favor of an ace? Then remember that the probability by definition is the number of favorable outcome, the ones that you are in favor of, out of the total possible outcome, which is the total amount of cards in the pack. So if we are to find the probability of drawing an ace, it means that we would have it be in favor of what? An ace. And so we would have to consider how many aces we have in the card pack. So it means that we would have 4 aces in the card pack. And so we would be in favor of, our favorable outcome would be 4, and our possible outcome would be 52. So we would have 4 over 52. And then we would cancel down that if we can cancel. And so we see that 4 can go into itself 1 time, and 4 can go into 52 13 times. And so this would simplify into 1 over 30. Is that clear to you guys?
Yes, sir.
Okay. All right, so 2 more examples on probability here. To find the probability of drawing a diamond from a deck of cards, we know that there are 52 outcomes. And we know that 13 diamonds are in the card pack. So our favorable outcome would be 13, and the total number of cards in the pack would be 52. So we would put what we're in favor of out of the total. So the probability of diamonds, the likelihood that we would get a diamond, or the chance of getting a diamond. We have 13 diamonds in the card pack, so the chance of getting a diamond would be the 13 out of the 52 cards. All right, 20 discs are marked with the number 1 to 20 inclusive. They are placed in a box, and 1 disc is drawn from it. What is the probability that the number of discs will be a multiple of 5? Now, if we have 20 discs, what would be the probability that a disc would be a multiple of 5? All right, so from 1 to 20, we only have 4 multiples of 5 that we would have. So we would have 5, we would have 10, and we would have 20. Those are multiples of 5. So of all the discs that are labeled from 1 to 20, 4 of them would be multiples of 5. So the probability of multiple of 5 would be 4 out of the total, which is 4 over 20. And we cancel it down. 4 into 4 goes 1, 4 into 20 goes 5. So our probability would give you 1. Is that clear, guys? All right. Okay, you're asking a question, Mr. Artie, or you're saying it is clear?
No, sir, I'm saying it is clear.
Okay. Are you okay with it, Miss Brown, Miss Waysome, Miss Cabrera, Mr. Bartley?
Yes, sir.
Miss Green? Okay. All right. Here we have what we call non-equiprobable events. Now remember, equiprobable event is when you have the same chance of something happening. Now, for non-equiprobable events, outcomes which do not have the same chance of happening are called non-equiprobable events. Now, if we toss 3 coins together, the possible outcomes are all equiprobable. Hence, the number of heads we could have is from the 3 coins. And remember, we're tossing 3 coins. That means when we toss the coin, how many heads that we can get within one toss of the 3 coins. We throw all 3 of them together. So if we toss all of them together, there's a possibility that we might not get any head, because if they all fall tails up, it means that we wouldn't get any head. So we can have the probability of not getting a head, which is 0 head. If we toss a coin again, we could get one head and 2 tails. So the possibility of getting the probability of a head would also be 1 head. And we can also get 2 heads. Now, if you toss the 3 coins together, 2 may turn up to be head and 1 turn up to be tail. So these are the possibilities of getting a 0 head, 1 head, 2 head, and 3 head. But what you notice about all of these probability, they don't have the same chance of happening. So the probability of getting 0 head, the probability of getting 1 head, the probability of getting 2 head, and the probability of getting 3 head when we toss a coin, these are all non-equiprobable events because they don't have the same chance of happening. Now, if you look at this diagram here, these are all the possible ways that you can get the coin when you toss them all together. So if you throw up all the coins together, you could get 3 heads. So that's one possibility. You could get 2 heads and 1 tail. That's another possibility. You could get so here all 3 coins could give you a head. The first 2 coins could give you a head. The third one would give you a tail. You could so this one, the middle one, could give you a tail, and the other 2 would give you a head, and so on. So all of these outcomes, in terms of getting a head, in terms of getting 0 head, you would count here. Getting 0 head would mean that you would get all tails, right, guys? So how many chances you have of getting 0 head? 1 chance of getting 0 head. So we only get 0 head when we toss it and we get all 3 tails. So out of these 8 possibilities, the probability of getting a head is 1 out of 8. The probability of getting 2 heads, you look in this and see how many ways you can get 2 heads. This one can give you 2 head. This one give you 2 head. This one give you 2 head. So you would find that out of the 8 possible outcomes, the probability of getting 2 head would be 3 out of 8. And the probability of getting 1 head. So this one give you 1 head. This one give you 1 head. And this one give you 1 head. So of all the outcomes, you only have 3 ways that you can get 1 head. All right. Now, so what we are saying here now, all right, let me look at the last one. The probability of getting 3 heads would be just one chance of that happening. So it's 1 out of 8. Now, how did we get the 8? Now, we would have all the possible outcomes that can happen. So once you throw the coin out, the 3 coins up, these are all the possible outcomes. So this is 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. The probability of getting 0 head would just be all tails. So that is 1 possible outcome out of 8. So if you're finding the probability of 0 head, you would only favor, your favorable outcome would be just 1 out of 8. The probability of getting 1 head, how many of these possibilities give you 1 head? This is 1, this is 2, this is 3. So you only have 3 favorable chance of getting 1 head. How many favorable chance of getting 2 heads? You have this chance of getting 2 heads, this chance of getting 2 heads, this chance of getting 2 heads. So you only have 3 favorable chance of getting 2 heads. And in terms of getting 3 heads, you only have 1 favorable chance of getting 3 heads. Now, what you are saying about this now, all of these, the probability of getting 0 head, 1 head, 2 head, all have different chance of happening. So they are non-equal probability events. So that's what we're defining. Non-equal probability events are outcomes that don't have the same chance of happening. So they do not have the same chance of happening. And so these events are non-equal probable events. Is that clear, guys? All right, so moving on. Now, another thing about probability, guys, is that probability can be represented using set notation. And we would have done set some classes back, some classes ago. But we are saying that in order to represent our outcomes in terms of, we can use a Venn diagram. All right, so here we have an example. Suppose U equal to the set such that 2 would be less than X and X would be less than 12. Now, if we think of these values to be in the universal set, because remember, U is the universal set, right? Let me just fix this diagram. Let me just fix this. All right, so back to, remember guys, just to be reminded, this is a set notation. And if you remember what this set notation is, it is called set builder's notation. And from in sets, you were told that you should be able to read this notation and list all the members. So based on what this notation is saying, U, which is the universal set, is equal, the curly brackets mean the set of elements X, the colon means such that 2 would be a value less than X and X would be a value less than 12. So what are the range of values you want? You want the range of values for X. X would have to be greater than 2 because 2 is less than X. So X has to be greater than 2 and X has to be less than 12. So the values that are greater than 2 and less than 12, 3, 4, 5, 6, 7, 8, 9, 10, 11 All of these are greater than 2 and they are less than 12. So this set would give you the universal set. All right. So if you are to find the probability that you have an odd number from this set, then what you would have to do is go ahead and pick out all the odd numbers in this set. What are the odd numbers? The odd numbers here, if we are to circle them, we would have 3, 5, 7, 9, and 11. Those are all the odd numbers. So in terms of the probability of odd numbers, we see that the set A would give you all the odd numbers. But if we count how many odd numbers we have, we would have 5 odd numbers. So it means that the probability of odd numbers, it means that the chance of getting an odd number is the amount of favorable odd number that we have, which is 5, over the total number in the universal set. So in the universal set, we have how many members we have in that set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 members. 5 of them are odd numbers. So we are in favor of 5 that are odd. So the probability of odd numbers will be number of odd numbers over the number of elements. Remember, n means the number of elements in A, and here n would be the number of elements in U. So the number of elements in set A over the number of elements in the universal set. Number of elements in set A would be 5. You simply count how many members you have in set A, which is 5, over the number of elements in the universal set. You just count how many members you have in that. And so the probability of odd numbers from that set would be 5 over 9. Now, this we also can represent using a Venn diagram, because we can label the set of odd numbers with A and represent it with a circle, and we would put all the numbers that are odd in that circle and all the numbers that are not odd outside the circle. So remember, all those members that are not in the set A would be the complement of set A, right? And another name for complement is the prime. So we could say A prime. Now, these are things that we would have, these are some concepts that we would have gone through in set already. So I'm not going to go into the details of explaining some of these, all right? All right, these are some things to note about probability. We have what we call the probability scale. So we say on the probability scale, the scale goes from 0 to 1. Can anybody tell me why you think the scale would go from 0 to 1? Why is the probability scale going from 0 to 1? Anybody?
Does it have a chance of it happening, sir?
Yeah, but why the scale start at 0 and ends at 1?
With the first attempt chance? Would it? I'm not sure.
And what else can
So
help?
are the probability of the event not occurring is like 0 chances.
Right, but remember I had mentioned something very important about when we are calculating probability. We say that our probability cannot be a number less than 0, and it cannot be a number greater than 1. So in other words, the range of values that you can get from probability can only go from 0 to 1. So you can get a probability of 0, and you can get a probability of 1, or you can get a probability greater than 1. You can get a chance of something happening to be 2. So remember, guys, probability values will only fall between 0 and 1. So that means most of the probability values will be fractions, right? So except for 1 and 0, all the other probabilities that you can have will be a fraction. Is that clear? So our probability scale can only go from 0 to 1. All right, so for the scale, we just use a line to represent the scale. And if we are to apply the probability of tossing a coin to this scale, right, we see that in tossing a coin, we can either get a head or a tail. Probability of getting a head would just be 50% chance of happening. Now, we use the probability of 1 and the probability of 0 to mean that if something has a probability of 1, it is certain to happen. If something has a probability of 0, that means it can never happen. It will never happen. So if anything that is certain to happen will have a probability of 1. For example, one day we must die. That is certain to happen, so that has a probability of 1. The cow jump over the moon. That will never happen. So that has a probability of 0. So anything that we can bet our life on, and we know that it's going to happen, we say that it is certain and the probability is 1. Anything that will never happen, we say that it is uncertain and it has a probability of 0. Is that clear to you guys? So the probability of 1 is certainty, and the probability of 0 is uncertainty, or it is impossible. So for something to have a probability of 0 means that it doesn't have a chance of happening. Right? So hence the probability scale goes from 0 to 1, and between 0 and 1, we are measuring the likelihood of it happening. So what you would notice on the scale, the closer the probability is to 0, is the less chance of that thing happening. The closer the probability is to 1, is the more likely that the thing will happen. So if you are calculating your probability of winning the lotto, and if you have 50 tickets and 100 people bought a ticket, that means you have a chance of 50 out of 100. So it means that half would be midway between 1 and 0. If you had, say, 75 tickets, if you bought 75 tickets out of the 100 tickets that were sold, then it means that you would have 3 out of 4 chance of it happening. That means you have a likelihood of winning the lotto because you have 3/4 of the tickets. So the more, the greater your probability in terms of the closer your value of probability is to 1, is the more likely that that outcome will be in your favor. All right. The closer it is to 0, it is the less likely it is to happen. Now, the total probability in terms of an event happening and an event not happening. So in other words, if we have 10 mangoes in a bag, and we have 4 of them would be Julie, and 6 of them East India. And if your preference for mango is Julie, that means you would favor Julie. So you would have 4, the chance of drawing Julie out of the 10. So your probability of getting a Julie would be 4 out of 10. What would be the probability of not getting a Julie? Can anybody answer that?
Repeat again, please.
Your connection is cracking up this way some. Can you repeat what you just said a while ago?
Sir, I was asking you to repeat the
Okay.
question.
Okay, I was saying that if I have a bag of mango, if I have a bag of 10 mangoes, 4 of the 10 mangoes are Julie. And then the remainder, which is the remaining 6 would be East Indian. And I'm saying to you that suppose you're in favor of Julie, what would be the probability of you getting a Julie from the bag? And what would be the probability of not getting a Julie from the bag? So that's all I'm saying.
The probability of getting the Julie, sir, would have been 4 out of 10, and not getting the Julie would have been 6 out of 10, sir.
Right. So it means that the probability of not getting the Julie would be the probability of getting the East Indian. Everybody see that? So if you're not getting a Julie, you must get an East Indian. But you're not in favor of the East Indian. What you're in favor of the Julie. So it means that the probability of not getting an East Indian plus the probability of getting a Julie, if you add those 2 probabilities together, you will get 10. Do you agree? Sorry, not 10 exactly. You would have, if the probability of getting and we call it, Julie is 4 out of 10, and the probability of getting an East Indian is 6 out of 10. So there are 2 fractions. So if you add the 2 probability, 4 out of 10 and 6 out of 10, you get 10 out of 10, which is 1. So what we're saying, the probability of getting an East Indian plus the probability of getting a Julie would be equal to 1. So we are saying the probability of getting what you're in favor of plus the probability of getting what you're not in favor of will be 1. And hence the total probability would be the probability of favorable plus the probability of unfavorable is equal to 1. So that is a very important equation that you will learn to use when we are looking at probability. So when we are looking at what we are in favor of with what we are not in favor of, you should always remember that the probability of what you are in favor of plus the probability of what you are not in favor of, you add the 2 probabilities, you're going to get 1. Now, how can this help us? It means that if we know the probability of what we are in favor of, we can calculate the probability of what we are not in favor of by doing what?
Subtracting.
Subtracting what? So suppose, let me give an example. So suppose we say the probability, let's say I have 20 mangoes in the bag, and I have 8 joules. Now, what would be the probability of joule?
8 out of 20.
So the probability of a joule would be 8 out of 20. Now, suppose I ask now, what is the probability of not joule?
12 out of 20, sir. So we would minus the 8 from the 20.
So probability of not joule could be calculated by saying that the probability of joule plus the probability of not joule we know that should equal to 1. So the probability of joule is 20 over 8. Sorry, 8 over 20. And we don't know what probability of not joule is. We could just solve the equation. How would we solve this equation? We would bring over this that we know to the other side of the equation. So we would say the probability of not joule would be equal to 1 minus the probability of joule, which is 8 out of 20. All right. Now remember, 1 is a whole number. But if we are to write this with if we are to represent 1 using the denominator of 20, 1 can be written as 20 over 20. So it would be 20 over 20 minus 8 over 20. And so we take away 8 from 20 in the numerator because the denominators are the same. So 8 from 20 would give you 12 over 20. All right, so this is just to show you that if we know the probability of something happening, we can calculate the probability of it not happening by subtracting what the probability of it happening. We subtract that from 1 and we will get the probability of it not happening. So that's all we are saying. So the probability of favorable can be calculated by subtracting the probability of unfavorable from 1. Or we can calculate the probability of unfavorable by subtracting the probability of favorable from 1. Is that clear, guys? Is it clear? So if you know the probability of something happening, so the probability of, say, if we know that the probability of something happening is a quarter, right? What would be the probability of it not happening? All right, so let's say we have some bars, and let's say the probability of red bar is equal to a quarter. What's the probability of not red bar? Then that would simply be 1 minus a quarter. And we can simplify this. We can convert 1 into a fraction by putting it as 4/4. We're using the same denominator here to give you the 1. As we know, 4/4 is the same as 1. So we use the same denominator, right? Write 1 as 4/4, then we subtract 1/4. So 1 from 4 give you what? 3/4. So this would now be the probability of not getting a red bar. The probability of not red bar. Is that clear, guys? And all of this is coming from this equation here. All right, that's where that is coming from. So the probability of favorable, meaning the probability of something happening, and the probability of it not happening. So for it to happen is the one that you're in favor of. And when it is not happening, it means that it is unfavorable. All right, is that clear to you guys? All right, guys. So this is where we're going to be stopping for tonight. So I'm going to stop share the screen now.